So in today's session, we will be discussing the previous year questions on engineering physics, especially on the module 1 and 2, which has come in the previous year. So I'll be discussing those questions now. So first question is, obtain the attenuation coefficient of the given fiber of length 1500 meter, given the input and output power of 100 megawatt and 70 megawatt. Okay, so let's see how it can be done. Yeah. So length of the fiber is given, input power Pi, P naught, output power, everything is there. The formula for attenuation coefficient alpha is minus 1 by L, Ln, that is log to the base E, P naught by Pi, power output by Pi. Then you just substitute the value and get it. So in the calculator, you will have a function called Ln. Okay, instead of log, just above that thing, there will be function Ln and just substitute it. We'll be getting the answer directly. So we just remember this basic formula. That's all. Simple thing. And final answer you write like this. Presentation is very, very important even in problems also. Second question. The speed of the electron is measured with an uncertainty of 2 in 10 power 4 meter per second one dimension. What is the maximum width required by the electron to be conformed in an atom? So here we know the Heisenberg's uncertainty principle. Correct? Del x dot del p is equal to h by 4 pi. So we all know what is momentum. Momentum is my p. Correct? Mass into velocity. P is my momentum, m is mass, v is velocity. P is my momentum. Okay, m is mass and v is the velocity respectively. So instead of delta P, I will put what? M dot delta V here. Instead of V, delta V, I'll be putting here. Please clear the screen now. Whatever. Yes. Now let's see the given values here. Yeah. Del X. Correct? Mass. So mass of the electron is what? 9.1 into 10 power minus 31. Uncertainty speed is given in the question 2 into 10 power 4. So this is the only thing which is given in the question. 2 into 10 power 4. Correct? Delta V. The speed means velocity. That's it. Momentum to calculate, we will put what? M dot del V. So we have to finally calculate del X. H by 4 pi. H is Planck's constant. 6.2626 10 power minus 34. 4 pi. 4 into 3.14. Then upon solving, we'll be getting the answer directly. It's a very simple question. That's all. So we can easily get full marks in the problem. So better to attempt the problem rather than the theory part. Next one. Calculate the ratio of population for a given pair of energy levels corresponding to the emission of radiation 694.3 nanometer temperature of 300 Kelvin. Again, this is the formula we have to use, the ratio of population N2 by N1 is equal to exponential of minus E2 minus E1 by KT. Now, we know the formula. Energy is what? Draw triangle. Energy is equal to what? H nu. H is my Planck's constant, nu is my frequency. What is my nu? C by lambda. C is my speed of light. Correct? Lambda is wavelength, nu is my frequency. This is my frequency. H is my Planck's constant. So now E2 minus E1, the difference in energy is nothing but what? Hc by lambda. Instead of nu, I am putting what? What is my nu here? From this triangle, C by lambda. C divided by lambda. So E2 minus E1 is equal to Hc by lambda. I'm just putting it. Yeah. Now, how we are going to get these values is, again, I'll just take the question for you. Given pair of energy levels corresponding to emission of 694.3 nanometer at temperature of what? 300 Kelvin. That's the question here. Okay. So coming to this, I'll be getting what the lambda value. And just pause it for a second. Yeah. So again, coming back to the recording here. Yes. So now coming to my energy value, lambda is only given. HC value, once you multiply the Planck's constant speed of the light, what I'll be getting is 1240 nanometer EV. 1240 nanometer EV will be the value of HC and lambda will be at 694.3. So this is the value which we have to know. Now also we should know that 1 electron volt is equal to what? 1.6 into 10 power minus 19 joules. So to convert this electron volt into joules, energy work, all of them, what is the unit? Joules. So to convert the electron volt to joules, I'll multiply by what? 1.6 into 10 power minus 19. That's all. So one part is over, this one. Now coming to the main question, N2 minus N2 by N1. Temperature is what? 300 Kelvin. Correct? N2 by N1 is equal to exponential of, what is the value we got? Minus 2.85 we got it. And E2 minus E1 value. So just substitute the E2 minus E1 value here. Correct? And the corresponding values. 1.38 into 10 power minus 23 into 300 Kelvin. KT. Let's come back. Yes. 2 minus 2.85 10 power minus 17 and 1.38 into 10 power minus 23 into 300. K value is 1.38 into 10 power minus 23. So upon substituting this thing, I'll be getting this answer. I'll just show you in calculator how to do that. This is taken from a calculator screenshot. So E power. Okay, in the calculator, take E power minus in the fraction. Put this value 2.85 10 power minus 19, 1.38 into 300 10 power minus 23. I'll be getting this value 126.74 into 10 power minus 32. Okay, or else if you want to make it to 30, 1.26 into 10 power minus 30. That is just the above calculation. So in this question, this is I think 7 marks or 8 mark question. In this question, we have to know 2 to 3 things. One is HC value, we have to know 1240 nanometer electron volt. Very easy to by heart and keep it ready. Then once you are getting, you should remember the formula N2 by N1 is equal exponential of minus 2.85 10 power minus 20 and K value we have to remember 1.38 10 power minus 23. Temperature is already given in the question 300 Kelvin. Just substitute it as in the calculator here. So you can pause the video and check how I have done it. This I taken from my own calculator screen. Okay. Yeah. So that's it. So I hope this session was useful. Thank you.